Hello everybody, I'm going to do some remedial surgery on this terrible noisy, electrically noisy EM radiation that blocks all my devices, stops my central locking from working, stops my Bluetooth mouse, kills my HDMI monitor link, and crashed the USB hub on my computer actually, which has been reliable, never crashed before. So it was a complete reboot to get that and a repower of the computer system to get it working. Anyway, so to reveal what's within, there you go, that's what's in there, and let's just point out the bits that are obviously missing. Right, so first thing we've got missing, as someone pointed out, I can't remember the YouTuber, that's the actual positive inrush limiter. These wires are around the wrong way, although it would make a slight difference to the noise, but not much in terms of RF. And so we've got the varistor is missing, so there's no input over voltage protection on this. There's a decoupling capacitor, fail-safe, fail-open, 275 volt AC working capacitor to go in there, and there's the common mode rejection choke. And nearly every design I've ever done or seen has a capacitor across the both sides of this choke for decoupling. And then here we've got the class Y capacitor, which connects the 0 volts of the output side to the power supply to actually conduct a lot of the RF interference or signal noise back down to the power supply. So that's missing too. So they've just basically left out all the filtering capacitors and components, all right? So, and the protection component there. So I'm going to put those in. If we look at a typical power supply, here's a Bose one. This is an old Bose unit, and you can see there's the common mode rejection choke. They've got two caps on the input and a cap on the output of that choke, and then it goes through the PTC and then into the rectifier to feed the B+, all right? And the class Y capacitor between 0 volts on here and the power supply is this one here. That's missing. You can see it's got the separation gap. It's a 2 kV capacitor, right? Fail-safe, fail-open capacitor. So we're going to put those in. Now on most power supplies, if you look on this power supply, it's an old Bose power supply, not even compliant with the new standards actually. It's probably 10, 12 years old, this one. It's just from a massive bin of old power supplies I've got this from. You can see it's had a big burn up, so it's not repairable. Two common mode chokes. This is a dual rail supply, so there should be a common mode choke in the output, the DC output leads as well, to filter out any common mode interference going down these leads here to the battery, to the outside world, and being transmitted as like a transmitter. Right, so if we just have a look for a moment, this is what I use for power supply development. You can see we've got this quite handy. This is the selection kit I use when I'm designing stuff, and inside we've got all manner of different common mode chokes specifically designed for this purpose, for filtration. Note that on the output side we would need something like a 9 amp choke, because obviously the core has to be big enough, the wires have to be sufficient diameter to conduct the 9 amps without overheating, and the core has to be big enough to work at those sorts of currents without saturation. Clearly once it's saturated it will no longer act as an effective inductor. And this one is a 12 amp 1 millihenry 9 milliohm, so we'd have to put something like that or something of that sort of size in the DC side to be an effective filter. There's one here which is an 8 amp one, so we'd probably get away with that one, although I didn't really want to use these because I use them for the professional design stuff that we do. So yeah, I'm thinking that that's a more limited, smaller 10 amp version as well, different inductance. So one of those probably. I'm going to do the mains input side and just see what impact that has on the noise coming from this thing, and might just leave it at that, and knowing that it's still non-compliant. I don't think with this arrangement here, with just as direct output to the battery, that it could ever be compliant, properly compliant actually. But we'll fire it up and have a look and see, shall we? So I need to locate these components, and I think what I'm going to do is just take the components out of this and then populate it onto that board. So let's go on with that. I'm currently looking for the mother sucker at the moment, which seems to have gone for walkies. There it is. So got the mother sucker. Just going to loosen up these connections with a little bit of leaded solder, just make it easier to flow. There's unleaded on there at the moment, and just adding a little bit of tin lead solder just makes everything flow more nicely. Yeah, it looks like I'm going to have to do a loosen and lever, or not, maybe not actually. Maybe I can get these out without having to heat it up and pull it out from the other side, which is never my preferred method. But sometimes you just have to resort to it if they've made the holes in the PCB too small. Can we loosen up these pins? That one's gone. That one hasn't. That one probably has. That one hasn't. So we need a bit more surgery on that one there. That one there. Solder back on, let it get good and hot, and then sucker off. Yeah, it's funny actually, they make these holes so small that it makes it difficult for the actual operator in production to actually locate the component in the holes, because the component legs are never absolutely super accurately arranged. So when I do them, I tend to make the holes a bit bigger so we can slap it in, because these components are added by hand. They're hand populated before flow solder. So there's a common mode choke, perfectly adequate for what we want. Okay, common mode choke, and we might as well just reuse these capacitors rather than fetching new ones out of the box. There's only a place for one of these on the post side, so this side carefully, slowly catch your monkey. There you go. I think that just fell out, didn't it? There she blows. So this one's a 0.22 microfarad, 250 volts AC, 275 volts AC actually. You can see that there. See that? So is that the right pitch for this one? It is the correct pitch, so let's just unsolder that. Yeah. What I did do today was, just out of sheer interest, is to order another one of these from Amazon. And the UK supplier made a big thing on Amazon that it's got the 13 amp UK plug on it. So in that case, I'm just going to order one and see whether it has got these components populated or not. If not, the importer is taking a big risk, because there are some, you don't hear of things like CE approved products being outed and then prosecutions being done, but it does happen occasionally. So let's open up the holes for the barister. There we are. And then back on this one, we'll take this coupling capacitor between the supply and the secondary side, the 2 kilovolt failsafe class Y capacitor. So let's just take that out. Yeah, I debated whether to do this or not, and I thought I might as well, because it would make a handy, oh, I've left my lights on, get me working battery charger of one of my kids, so I'm going to pass it on to them to use, stick in the boot of their car, and then use if they need to. There we go, so she's out as well. So we've got her out, okay. Take the silicone off it. Put her into here. Suck our holes off first. There's that point there, isn't it? A little bit of protection. So that will mitigate some of the noise coming from the secondary side by conducting it back to the power supply. Also, someone pointed out, even though this was delivered with a 2-pin plug on it, they've got the live and neutral wires round the wrong way. It won't make much difference, but I'm swapping around the right way just for sheer comfort. We'll swap those over. Can't find the hole. It's a problem I've been having lately. Right, so there we are. Into that one. Into that one. Give them a bit of a trim. So one component left. The varistor. Hold on. Where are my varistors? Off to the cupboard of plenty. Yeah, here's the box of varistors from the cupboard. Varistors 275 volt, large ones. These have got quite a large capacitance actually, so in their own right they are a noise filtration as well as an over voltage protection device. They're good for noise filtration. That's no good. That's no good. That would do is a bit small. That's a capacitor, that's a capacitor, that's a capacitor. I'm going to put one of these in. 275 volt AC working varistor. Anybody who not use this company to buy your components, you can buy at almost Chinese trade prices on there. Not everything, but you know, varistor, 5 cents, one of those, compared to 50p in the UK. So 275 volt AC working varistor going in now, a nice big one. Soak up any nasty transients. They're not particularly fast, but the fast transients will be soaked away by the capacitor. All right. Stop any common mode interference going out. These are opposite. They're wound in opposite directions, so that any common mode currents which could go down the mains are actually cancelled out by conducting them to each other, by coupling them to each other, thereby providing a path for the high frequency component of the common mode signal on the power lines. Let's do something slightly different on this. Let's cut these wires here, and then we'll pull them out. There you go. So, will this fit? Has this got the right hole spacing? Are we into some surgery here? We are into some surgery. The coil they have fitted is very small. I wonder if any of these ones in my actual kit will fit. Yeah, so if I place it in like that, It should go in. There we go. It goes in, but will that foul on the... I think that's going to foul on the support post, don't you? This post comes down through to hold this board, and that's in the way, so that's not going to fit. That is a very good choke. Yeah, so I think one of these with the legs bent will fit out of the kit. So the pitch is correct for the end-to-end on the winding, but the pitch isn't correct for the span. So I'm going to solder that in there like that. Get some copper wire. But Jesus, where's the copper wire gone? Right, I was always taught by the guys in the aircraft instrumentation place. When I was 16, I left school and went and did a day release for ordinary National Certificate in Electrical Engineering, and we were always told you could never make a lap joint with a soldering iron, soldering two wires together. The approved method was to use a mechanical joint like this. So you put a loop of wire in, and then we're just going to bend that over there, and can we get that through that hole and still connect it? This is the question. Solder the component leg on. So remove the detritus off the bench. So that's what it's looked like with all the components mounted. Okay, we've got our filter, we've got our capacitor, we've got our varistor, we've got the class Y over here. The only thing that's missing off this side is another capacitor. There should be one of these at least on this side to complete the construction of the filter. I wonder if there's room to actually fit one on the back. What do you think? How close? If you look at this design of this base, it sits over there like that, and that point there is just there. And there's quite a sizable gap underneath, so I'm thinking I can just put one straight across the back of there, actually. That's what I'm going to do. So where's that box? It's a bit on the small side, but it's a Chinese capacitor, but it'll do for this. It's not going to be left switched on. It's not connected to anyone's life support. So what we've got, yeah, 82 nanofarad, 275 volt AC, which is pretty bloody small for that value. I bet it's not. Should we just put it on the meter? No, that's not bothered. That's not bothered. I bet it's not. I'll do a thing on Chinese capacitors. Chinese capacitor education at some other point. Anyway, a small decoupling capacitor to drastically increase the filtration, reduce the noise. Got everything we need really in theory to protect the input side to some degree, not to a measured amount as required by CE, but who is gonna tell us off? Who's gonna come and say no, don't do it that way? It will be quite interesting to see whether it just allows my HDMI monitor to carry on working or not. So this will be a good test as to whether we fix the HDMI link shutdown that's been occurring. As soon as I turn this on before, you can see on the other video, my monitor screen, which is not even connected to the same circuit, shuts off. Right, so let's put that over the top. Not going to bother with the fan at the moment, are we? Or are we? Where is the fan? Fan's around here somewhere. I'll find that. There's the fan. Yeah, we'll plug that back in. Not going to be doing anything, obviously. Okay, so put that in there. Rest it on the top. Alright, so, yeah, ready for contact. Set this to 12 point, connected up correctly to the battery clips. We're connected. So, as soon as I hit this power, it should come on without a bang. Just check what we've done. I think we've done the right thing, don't you? I think we have. Should come on without a bang and start working. We'll see how noisy it is. Okay, so we're charging now. We're charging and my monitor is still working, I'm pleased to report. So we solved the problem of the monitor being blanked. I can show you now. Here's the modified unit. And there's my monitor working okay. So it's fixed that problem. So it was on the main side. Anyway, it's a much better product now. I'm not going to bother messing about with it or measuring it, but it's stopped the interference. And let's face it, it's going to be at least several orders of magnitude less with those filter components fitted. So put it back together and pass it on. So yeah, so it did solve the problem, and we've got a lot less noise. So I hope you hope you enjoyed watching that, and then if you can subscribe down there, that'd be good, or leave me a like, that'd be great. Yeah, that's what the pulse repair waveform looks like now after the filtration components have been put in. You can see it's significantly less noisy than it was before. If you compare to the trace on the other video, the scope hasn't been changed, it's set to the same settings. Because there's a lot less impressed noise on it. Still quite a bit, but way less than before. So I'm leaving it like that. So I shall pass it on. So put it back together and pass it on. So yeah, so it did solve the problem, and we've got a lot less noise. So I hope you hope you enjoyed watching that, and then if you can subscribe down there, that'd be good, or leave me a like, that'd be great.